Welcome to this video tutorial. In this video tutorials we will touch some of the things that we have learned during the different units of statistics too. So I recommend you to pause the video and read carefully the statement, and then after that I will develop the solution. In this case we are interested in analyze if there are some differences between the mean speed of the vehicles in the city of Barcelona in 2 different periods of time. So in order to do that, we have record in 30 minutes how many kilometers have drive some cars. In the first period time, we have a sample of 15 cars, and the sum of all the kilometers in these 30 minutes have been 570. And the sum of these kilometers in 30 minutes to the square is 21,896. In the case of the second sample, we have a sample of 12 cars, and the sum of the kilometers are 240, and the sum of the kilometers to the square in this period of 30 minutes is 5,018. We assume that both distributions are normal in origin, and as a normal distribution are characterized by the expected value and the variance, but in that case we can assume that the variance are equal. So in that case we have the same variance for both distributions. If we want to build the hypothesis test and we want to check if there are some difference in the mean speed in both periods of time, we are going to build a hypothesis testing where the null hypothesis is going to be that the means are equal in both periods, and we are not interested in knowing if it's greater in the first one with respect to the second one or in the second one with respect to the first one. We can assume that the alternative is going to be unequal. So the alternative we will have if these two means are not equal between them. You know that if you develop both distributions and you build the sample statistic that is the difference between means, this difference between means is going to be distributed as a normal with the expected value equal to the difference between both expected value, and the standard deviation will be the square root of the sum of variances coming from both original distributions. So in that case we have solved one of the problems that we had two unknown parameters, and now as we can assume that they are equal, we have only one unknown parameter, but we have to solve this problem. As the samples are not enough big, the best way is to compute the weighted variance that is computed as you can see on the slide. That is a way to weight both variance coming from both populations. This computation is equal to 18.16, and in order to check if this statistic is outside of the region or is greater and lower at the same time of both critical values, because we have to search in both tails of the distribution, we can compute the absolute value of the statistic, that is the difference between our sample means, 38 minus 20, less the difference between both parameters under the null hypothesis, that in that case is 0, divided by the standard deviation, that is equal to 4.26 multiplied by the square root of 1 divided by 15 plus 1 divided by 12. If this statistic is greater or lower than the critical value, in that case in absolute terms is equal to 10.9. If it is greater than 2.0595, we will reject the null hypothesis. This 2.0595 is the point over the axis in the test students that led alpha divided by 2 to the right side, and minus 2.0595 is the point in the lower chain in negative source that led another alpha divided by 2 probability to the left side. So as the value of this statistic is greater than this critical point, we can reject the null hypothesis.